Welcome back. Let's continue with our discussion about creating keys for the substitution cipher. In the previous video, we went through a function which takes a version of the alphabet, alphabetically, A through Z plus a space, scrambles it randomly to produce that key. That works, but we can do better. We can write a method, or write a function rather, that creates the 27-character key based on some password that we provide. So we'll use a password, which should be easier to remember than the entire scrambled version of the key, to produce a key that could be used in the substitution cipher. So here's our strategy. First of all, we'll take a look at our password and remove any duplicate characters from it. Secondly, we'll split the alphabet into characters, all those that come before the last password character and all the characters that come after the last password character. Then we'll remove our letters in the password from those two strings, before last and after last. And then finally, form our key by concatenating the password, the after string, and the before string into one large 27-character string. All right, so that can be found in listings 3.8, 3.9, and 3.10 of your text. So let's take a look at those. We look at 3.8. What we're doing is we're building up using that divide and conquer or top-down design strategy to take a large problem and decompose it into smaller pieces. So the first part is removing duplicates. So here's what we're going to do. Our function takes a string as a parameter. It will return the new version of that string, which would be that string minus any duplicated characters. And then for every character in the original parameter string, if that character is not in the new string already, then we will concatenate it to new string. Okay? So for every character in the original parameter, if it's not already in the new string that we're forming, we add it and then ultimately return that value back. So that's the remove dupes function. And then we have another function here called remove matches. And so this takes anything from remove string and removes it from my string. Right? So we have two parameters, my string, which is the one we're modifying, remove string, which is the one where the characters we're eliminating. So again, we start new string as a blank string, so we can use the accumulator pattern. Go through every character in the string that we're removing matches from. And if that character is not in the remove string, then we concatenate it to our new string. And then when the for loop is done, we return that value. So let's see those two functions in action. Here's our alphabet. We were forming again via this ASCII lowercase string from the string module, and then calling remove dupes on top secret. And there you go. So now, for instance, the second T is gone, the second E is gone from top secret. If we do the same on the string Wonder Woman, we got Wonder Ma because the second W is missing, the second O is missing, etc. Now, if we take a look at removing the matches, remember alphabet is all of our letters, and we're going to remove top secret from that, or top seeker, because we've already removed the duplicates there. And now the symbols that weren't in this string that were in the alphabet are now in the returned piece. And we could do the same by calling remove matches on alphabet and remove dupes on the Wonder Woman string. And there are the characters that were in the alphabet but not in the non-duplicated version of Wonder Woman. Then we can look at our actual key generation piece now that we have those two sub-pieces done. So again, we form our alphabet. These two lines here are as we've seen before. lowercase the password so that we're not dealing with any uppercase numbers, remove its duplicates, any duplicates from the password, get the last character in that, find the index of that character in the alphabet, and then our after string will be the result of removing the matches on the slice of the alphabet that starts after the last character of the password and goes to the end, and removing the password characters from it. And the before string will be the alphabet up to, but not including, the last character of the password, removing all the password characters from that. Then we can concatenate them together, password plus the after string plus the before string, and return that as a key value. So now we can execute that. Here's our password is top secret, and now it will create a password from, or a key from that. Notice that it starts with the password and then has all the other pieces of the original alphabet, and they're in order but with the duplicates removed. So you see A, B, D, F, G, H, I, etc. Is the first part of the alphabet minus words or letters from the non-duplicate version of top secret. And likewise, we can do that with Wonder Woman. Okay, so that might be a more handy way to generate keys via a password. Section 3.7 of your text, the Vinegar cipher. If you want to, go ahead and read through that just to get an idea. Basically, it's a substitution cipher that uses 26 different keys rather than a single key. But there's really nothing new in there from the point of view of learning Python or learning how to program, so we're going to leave that part out and not look at it in detail. But I would encourage you to check it out just to see what it is, because it's kind of a cool idea. All right, so that will wrap up our coverage of Chapter 3.